How do composite numbers from patterns on a number spiral? Have you ever wondered how numbers can create fascinating shapes and patterns? Today, we will look at composite numbers and how they form unique patterns when arranged on a number spiral. First, let's clarify what composite numbers are. Composite numbers are positive integers that have more than two factors. This means they can be divided evenly by numbers other than 1 and themselves. For example, the number 4 is composite because it can be divided by 1, 2, and 4. Now, let's talk about number spirals. A number spiral is a way of arranging integers in a spiral layout. It usually starts with 1 at the center and moves outward in a consistent pattern. Two popular types of number spirals are the Ulam spiral and the Sacks spiral. In the Ulam spiral, prime numbers tend to cluster along certain diagonal lines. Meanwhile, composite numbers fill in the spaces around these primes. This arrangement is not random. Instead, composite numbers often align along curves or bands that relate to their factorization properties. For instance, some diagonals in the spiral correspond to quadratic polynomials. These polynomials produce mostly composite numbers because they can be factored into smaller integers. This means that as you move along certain paths in the spiral, you will find many composite numbers. The Sacks spiral takes a different approach. It highlights patterns among composite numbers by scaling points based on their degree of compositeness. This degree measures how many prime factors a number has, counting multiplicities. As a result, you can see families of curves where numbers with similar factorization properties cluster together. These patterns arise because the spiral layout transforms linear sequences of numbers into geometric shapes. The algebraic properties of numbers, such as divisibility and factorization, translate into geometric regularities. For example, numbers that share common factors often lie along specific spiral arms or curves. This means that numbers leaving the same remainder when divided by a fixed number from their own spiral paths. Understanding these patterns can help visualize number theory concepts. It can also assist in identifying properties of numbers, such as whether they are prime or composite. Moreover, these patterns connect to deeper mathematical results, such as Dirichlet's theorem on arithmetic progressions. This theorem explains why primes and composites distribute in certain residue classes. In summary, composite numbers from patterns on number spirals by clustering along curves and lines determined by their factorization properties. These patterns reveal the underlying structure of numbers, making the concept of compositeness visually engaging and meaningful.